One other place where generic delegates can be extremely useful is when you need to raise events. So let's say that instead of using a buffer, we're now using a circular buffer. And because we're using a circular buffer, and let's say it has a small capacity, like perhaps just 3 items, we want to know when an item is being discarded from the buffer because it's full. We want to know the item that was discarded. We also want to know the new item that was forcing the ejection of the old item. And one of the best ways to do that is to raise an event from the circular buffer whenever we've reached capacity and we're kicking something out. In the old days, before generics, raising an event meant I typically first had to define a custom delegate and then define an event using that delegate type. But these days I can usually skip that first step of defining a custom delegate because there is a delegate type event handler, which is in the system namespace, which we currently don't have, so I'll have to pull that in. But event handler is something that can point to a method that always takes the first parameter of type object. You probably know when working with events, the first parameter to an event handler is always the sender, which is typed as object. If you don't remember that, we'll see the code here in just a bit. And then the second parameter is some sort of event args. What type of event args? Well, I can specify that as the generic type parameter to event handler. So if I name my event item discarded, I now have an event that expects to be handled by a method that takes an object as the first parameter and event args as the second parameter. Let's see that real quick. If I come into my buffer and say buffer.itemDiscarded plus equals and then hit the tab key twice, Visual Studio will fill in the event handler for me, create it for me. The event handler is a method, buffer_itemDiscarded. It takes object as the first parameter, that will be the sender, event args as the second parameter. Now, the problem with event args is that event args makes it very difficult to pass along any additional information because there's really no properties I can set on event args. If I need to pass along things like what item was discarded, what's the new item, I really need a custom event arguments class. So let me create one. Item discarded, event args. Like all good event argument classes, it will derive from event args as a base class. And now what I need to do is expose the discarded item as a property, so someone can look and see what was discarded, and also to expose the new item. But what type are they going to be? Is it going to be int, double, date time? I don't know. But once again, generic type parameters can help me out, because if I make this item discarded event args of t, I can now use t throughout the class definition, once again parameterizing the type, so we can use it with all sorts of different objects. So item discarded will be of type t. The new item that is being added will be of type t. And now let me just define a constructor. A constructor where you have to pass me the discarded item and the new item. And all this constructor has to do is say item discarded equals the discard and new item equals the incoming new item parameter. And now, instead of using event args as my event arguments, I can use item discarded event args of t. So still need that generic type parameter, but fortunately t is available since it's already here on the class as a generic parameter. So when it's circular buffer of double, it will raise an item discarded event args of double. And just like we've seen time and time again now, that t can just flow throughout the class. Now the last bit of work inside of the circular buffer would be to raise that event when something is about to be dequeued. So let me actually capture the value that's being dequeued and then call a method, let's call it onItemDiscarded, that will raise an event that will have both the discarded item as well as the new value. And I can use Visual Studio control period to generate a method stub for me. I'm putting this in a separate method because it's kind of messy to include all the code that needed to raise an event right here inside of the write method, which is really concerned with other opportunities. So inside of onItemDiscarded, first of all, check to see if anyone cares. That is, if item discarded is null, no one has subscribed to the event, there'd be no reason to raise the event. But if it's not equal to null, I need to put together some event arguments. So give me a new item discarded event args of t and pass in the discarded item and the new item. And then because item discarded is essentially a delegate, I can invoke it, passing in myself as the sender and args as the event arguments. And that should conclude our implementation for this event. We'll switch over into the program to see it work here in a second. But the whole key to this is to use the event handler of T generic delegate to define my event. And that means I don't need to define my own delegate. It can work with all sorts of different types. Whatever types of event args that I want that event to raise, I just need to specify it as a generic type parameter here. So now back in the program, let's clean things up a bit. The definition for this event has changed, so I'm just going to undo the code that was there from earlier. Also, I'm going to take out the part that is mapping the items to a date. Don't really need to concentrate on that anymore. And let's wire up buffer.itemDiscarded again. Use plus equals tab and tab to generate this method. Now you can see it is properly taking an item discarded event args of double. So Visual Studio could certainly figure out what we needed thanks to generic type parameters. And now let's provide an implementation for this to write out the information, what item is being discarded. But first, I'm going to control RR this method name, so refactor rename, and just call it item discarded. That looks much better. And now I can console.writeLine a message. So buffer full, discarding parameter 0. New item is parameter 1, and I just need to pass in e.itemDiscarded and e.newItem. And with that, hopefully I can run this program and see things being discarded. So let's enter a 2.1 and a 5.6 and a 3.2. At this point, the buffer should be at capacity, so if I enter 5.5, we discarded the 2.1, but we added the 5.5, and it looks like this is working correctly. I can end the program, see that it dumps out the right values, it's still summing things, and now it's raising an event thanks to the event handler of T.